Hey everybody, Garrett from AppMap here with another runtime analysis deep dive. Today we're going to be exploring a maintenance rule of ours called too many updates. We're going to be looking at what it is, what it kind of exposes to us, and what we can learn about our application when this finding appears. We can talk about how it happens in the wild, and we're going to look at a couple examples, and we'll talk about mitigation strategies that we can employ to be able to resolve this issue and prevent it in the future. So first things first, let's go talk about what we're dealing with. We define it as too many updates here at AppMap, and what it means basically is that this rule is verifying that the number of SQL and RPC updates performed by a command, function, or method really inside of your application does not exceed a certain threshold. That threshold that's set by AppMap inside of our default scanner.yaml is 5, right? So anything over 5 calls coming from the same function or method is going to throw this finding and show up in your findings results. If we want to take a look at the technical definition, it's identified as the CWE 1048 invocable control element with a large number of outward calls. Since that's a mouthful, I'm going to be saying too many updates, but they refer to the same thing, right? So let's talk about our application, and then we'll talk about, while we look at some of those examples, we'll talk about some of the causes of why this happens, right? So first things first, we're looking at a Spring Pet Clinic application running with Java and the Spring framework. And what this does is basically allows us to manage owners, pets, and visits for a veterinary clinic. I've gone ahead and created my own owner here with my name, all my information, pretty standard. I've created a pet named Jimmy. He's a bird, and we just completed a visit to our veterinarian for him limping, which for an animal with wings, I don't know why that's a concern of mine, but apparently it was. So let's go take a look at our code. First things first, I actually want to show you how to override that default. Right? How to set up your own override and your own threshold to be able to utilize this to your best of your abilities. I've created an appmap-scanner.yaml, which is the override for the defaults. And as you can see down here, I've set a rule, too many updates, and I've given it the property warning limit. When I went in and did it before, I set it as 1. Now, in the real world, we don't want to do that unless you're being a stickler to say, hey, no more than one function call, no more than one outbound call from every function. Seems a little extreme for me, so that's why we kind of set the default as 5, right? Anytime there's more than 5 calls, we should probably be notified. Sometimes it's by design, sometimes it's by accident. We can take a look at that. But let's go take a look at an actual finding. Inside of our findings overview, and this is my favorite view, the way I get here is I go to the AppMap extension and I click on runtime analysis and I just look at my findings table, right? And I have everything. And this is my favorite view because I can see every finding that I'm looking for. Otherwise, we can take a look at just that dropdown. That dropdown now has the ability to group all of your findings by project. Before, if you had a workspace with multiple projects and you had findings, they just all showed up carte blanche, and it was kind of difficult to understand and tell what was going on. So we've worked really hard to be able to group that a little bit better for you, grouping it by project, by findings. We can even group by date if you do this across multiple days or look at it for multiple days, and we group by category. So underneath the maintainability category, if we were to drop down this too many SQL updates, and let's just go ahead and pull our largest example from the bottom, we can open up our findings report for this specific app map. And as you can see here, this is our first example that we're going to take a look at. And before we do that, I want to talk about kind of what causes some of these updates. And we'll use this example as a parallel. We're going to open up the app map. And as you can see in the event summary, the command performs 47 SQL and RPC updates, or RPC updates. In our case, it's SQL. So let's go take a look at the app map. And we're actually going to take a look at the sequence diagram when it pulls up. But this is indicative of whenever you see this error, when I say error, but whenever you see this finding, it's indicative of a couple things. The first thing it could be indicative of, or it could be a canary in the coal mine to show us that, one, we're using poor coding practices. Something that should be probably condensed into a single call isn't being condensed, or something, or the way we're structuring or architecting our application could be flawed. That's not always the case, but it could be flawed. The other thing it looks at is maybe we need to take a look at reducing or restricting some of the calls that are coming in, just for security and safety purposes, to make sure that if we have any outbound calls that come into our API or application, that we can't they can't inundate our system, overload it, and shut it down. So if we take a look at this actual application, what we see is inside of the main, I have 47 different calls to a database. 47. Now, in our instance here, this is for setup, and it's specifically doing migrations to be able to set up our database so we can use the application. But I have actually seen that over time, while maintaining an application and changing the way the data is structured, we've actually had developers who have inserted multiple statements or updated multiple statements inside of the same function, and it's incredibly hard to tell what is actually happening inside of this function. This is the exact issue we're talking about. This is the root cause. Maintainability over time and adding functions and functionality to methods that shouldn't necessarily be there. Let's go take a look at another example and we'll kind of compare and contrast them. We're going to go ahead and close this app map. I'm going to hop back out to my findings overview that I left up here, and we're going to go take a look at our top app map. And as you can see in this one, because I set the threshold so low, it performs 2 SQL updates, right? Normally that threshold is 5. I set it at 2. If we go take a look at the sequence diagram again, we can decipher what's happening. For this specific application, let me just go ahead and close the side window here, or the sidebar here. For this specific application, this is adding a pet to an owner. So when I registered Jimmy, our awesome bird, this is the process that it went through. First thing we do is we find the owner, we go ahead and get all their information, we set it up inside of objects, create an object so that we can work with it and mutate it and do whatever we need to do. Then we come down here to this process creation form where I actually filled out the information for my pet, which is giving it a type, a birth date, and a name. And we can see inside of this function, we insert that exact information into the database. We insert it into ID, birth date, name, type. It gives it the ID by default, but you get the point. Then, because he's my pet, we need to associate that to an owner. So we update the pet and we set the owner ID as a foreign key, where our ID equals the same as the pet we just created. This is the canary in the coal mine that I'm talking about. This situation isn't necessarily a problem with the way we've architected our application. It isn't an issue with the way we've structured or any of our services that we've created or any of our abstractions. This is a designer and a developer choice to create 2 separate calls. So as somebody who would be reviewing this code, this is probably where I'd want to take a look at this specific instance, where I could say, could this be combined into one specific call? So that in the future, if we had to add an update where let's say we had a primary care physician for our bird, and we had to add that pet or add that veterinarian to our pet, we would do it here, but that would call another update, right? So the idea there is, can we consolidate or can we condense this into a single call so that we're not having that issue? And that gets us kind of into some of the mitigation options. That we have a bunch of different options that we can play with. First one, very simple, refactor. Take a look at it, refactor your code, see if you can get it into one. And that would probably be my suggestion in that case. This is opinionated. This is just Garrett's idea. You would probably want to refactor this code. The next option, and this is kind of like if you were trying to dig a hole, grab a stick of dynamite, it's probably not the way to go, but these next 2 options are kind of taking that approach. The first one is to abstract on top of a layer, create a service that you call that does your updates for you, pass it the information that you need, condense those into a single call. Seems like a lot of headway and a lot of architecture. A lot of the times, all we need to do is refactor. The second one is really let's absolutely go overkill on this one, would be to install a rate limit on this service to say, hey, you cannot call more than 5 times. That one I believe is overkill. In contrast, it can protect you against certain things for security, like a DDoS attack or other issues, but I think it's overkill. But the beauty about this is this is indicative of things we need to change in our code. And it's a great teaching moment for anybody who's a senior developer. It's a great learning moment for anybody who is a junior developer, because it allows us to use the tools we have at our advantage to change the way we code and make our code better. Specifically, in this case, we're using AppMap to take a look at something we could have done more efficiently, or something that will help us prevent performance issues and maintainability issues in the future, and we're changing the way we think about the problem to prevent ourselves from running into those issues. So thanks for joining me today. Once again, as always, all of the links are in the description down below, including a link to the repo, as well as to any of the documentation that I've used today. If you have any questions, comments, concerns, don't forget to like and subscribe and leave them down in the comments, and I'd be more than happy to answer them. If I forgot anything or misexplained anything, I'm here to learn too, so please just let me know, and we'll see you guys next time. Thanks.